My name is Ron Victor. I am the founder and CEO of IoTeam. Thank you for taking the time to come and give us a listen. Yorkland Controls is our distributor right here in Toronto, Canada. So Yorkland has sponsored this session, and we'll talk about deployment complexities and security issues in smart buildings. And we've broken it up into owner, operated, and managed properties is one market segment. Large SI, like him who managed 1,200 branches, it's another market segment. And the third market segment is a small SI who's managing 50 to 100 buildings, right? So we've got these three, and we'll talk about it. We are a network infrastructure software company. That's the first thing. We're a software company, number one. Number two, we're in the network infrastructure space. That's number two. We're a bunch of guys out of Cisco, Juniper, Qualcomm, Wind River, and SafeNet. So if you look, what does that mean? The DNA of the company is routing, switching, networking, security, and embedded systems. That's it. We've been around 3 years. We are a venture-funded company. We have been funded by GE Ventures, Juniper Ventures, and March Capital. We have been commercially deploying product for a little more than a year today. Our customers include verticals in building automation, oil and gas, power and utilities, and medical systems. To date, as you can see, we have already connected 60 buildings. Our customer base, CBRE in the US uses us for connecting all kinds of buildings, etc. We are, as I said, commercially deployed in about 60 buildings. The mission of this company is one and only one thing: to be able to securely connect a legacy brownfield mission critical asset that has been traditionally air-gapped or not connected to a greenfield application in a public-private hybrid cloud or a public hybrid or private data center without ever having the need to get IT involved. That's the key word. To connect a legacy brownfield mission-critical asset that has typically never been connected or has been air-gapped to a greenfield application in a public-private hybrid data center or cloud without ever having to call an IT person. Why did we do this? Why did we build this? There are 5.6 million buildings in the United States. There's 1.6 million oil rigs. There's 40,000 locomotives. Now think of you that are involved in the IT space. What does it take to connect an asset? If you have to connect 5.6 million buildings, how many Cisco routers are you going to need? How many Palo Alto Networks firewalls are you going to need? How many Cisco certified engineers are you going to send out to the field to command line and configure all this routing? How many whitelist rules will you have to change? How many proxy settings will you have to mess around with? You see the scale of the problem. So prior to doing this, and we'll make this you can feel free to stop me anytime and talk. I'll repeat the question for the recording, but we can make this a conversation. It's much better than me just talking. Prior to doing this for 4 years, I was connecting aluminum smelters, copper refineries, and zinc refineries. You want to connect something really hard to connect? Go in the middle of nowhere, like Sept-Îles in Quebec, where there's a plant by a company called Alouette, which runs aluminum, right in the middle of it. They have 400 aluminum cells in line, and these are huge cells transmitting 300 amperes of current, just going like insane. To connect like 10 of those took about 3 of us 2 weeks. To connect 10 of those. There were 400 and there were 4 lines of 400. We were trying to wire this up, just connect it, pull data off to get 1% efficiency in energy consumption. Because aluminum is the biggest culprit of, by the way, that's FYI for you. Aluminum consumes the more ridiculously large amounts of energy, and 50% of it is wasted. So it took time. That's when this thing started, like, this is insane. This is going to, there's 400, 400, 400. How many people do I need to hire? How many years is it going to take? That's when this idea came about, which said, once and for all, we're going to solve this transport layer problem. We're going to make it as simple as a DSL modem. Plug and play, a device reaches a machine, you plug it in, you turn it on, it's connected to an application. No command line interface ever required. Nobody has to go with a keyboard and type anything. Absolutely no changes to an enterprise firewall or proxy policy for the banks. Nobody's going to change a proxy policy in the bank just because you have to tunnel out. Absolutely no APN or VPN. Eliminate the APN and the VPN completely. Why eliminate the APN and VPN? Because at best we can remember 4 passwords, 5 passwords, 7 passwords. So what do we do if we're connecting 300 buildings or 1200 branches? We will have 1200 usernames and passwords, which will be on an Excel spreadsheet, which will be rotated to 50 technicians because they all have to remotely log in. One of them leaves, he's taken all of them. We have to rechange all the usernames and passwords for all 1200. So that whole architecture makes absolutely no sense. So eliminate all usernames and passwords. And lastly, never have to call an IT person to whitelist a rule or change a proxy setting. You all know how long it would take. If you went to an IT department and you said, I want to tunnel out of this building, could you please whitelist me? That will go through 6 months of approval before somebody signs off on it and saying you're okay to be whitelisted. Rightfully so. They're protecting enterprise data. Why will they let you just whitelist? So now we're talking 5.6 million buildings, 6 months per building to get whitelisted. I mean, insanity. So what did we do? This is, oh, I'm right here. Here. This was my requirement to my engineering team. Real awesome. All 25 years experience in Cisco, Juniper, Qualcomm, all these guys. I said, you guys are used to making all these routers. You assume there's a human being next to the router typing some command line interface. I want you to build something where nobody is required to sit on it. Why? Well, how am I going to, if there's a patch that has to be patched at 5.6 million buildings and somebody has to hit enter, how am I going to send so many people out to 5.6 million buildings to hit patch this, enter? Just think real common sense, right? When Microsoft sends you an update on your laptop, what does it say? It says, shall I update now or click next? If you have to click next across 65, 80 buildings of his, how long is it going to take before he sends people out one truck at a time, click next, and that happens every month because there's a new patch. So the fundamental requirement when you're connecting all these legacy assets, no command line interface. 100% managed from the cloud, not 99.9. 100%. You will never have to send a body out with a keyboard to plug something in on site and type something. Moment you have to do that, that solution is unscalable. His 1200 branches will never get connected because his CFO is going to look at the cost of provisioning those 1200 branches. He's going to say, you're nuts. 1200 times a Cisco certified engineer, 3 hours at $300 an hour, that's $1,000 over there. 1200 times 1000, that's $1,200,000 for just this guy. Forget the Cisco equipment, the Juniper equipment. Insanity. Let's keep it unconnected. So you cannot have a command line interface, period, number one. Number two, that automatically leads to the no truck roll. Because you all know in this business how costly it is to run a truck. In the US it's about $1,000. Anywhere from say, 600 to $1,000 every time you send a tech out to a building. And his is 1200 branches, his is 80 branches, yours is one building, whatever is the number. That scale is just not possible if you have to send a truck out. Usernames and passwords. I explained the problem already, right? You can't have 1200 usernames and passwords, one for. The reason people take a yellow sticky, write username equal to this, password equal to that, laminate it and tape it next to something is because they cannot remember it. That is the reason it happens. The biggest flaw in security is username and password. The biggest flaw, right? I mean, think about it. All I need to do is go and steal a username password and I'm done. I'll enter 1200 of his bank branches. So you cannot have an architecture that works on it. So now what do you have an architecture then? You base it on certificates and keys completely. Full PKI infrastructure at the back. There is no username, password. Eliminate that completely. Lastly, no changes to the existing enterprise IT firewall and proxy policies. A conversation that would normally start with IT now ends with IT. What does that mean? People go through all of this. I have a 40-minute conversation at the end. I produce all my pen testing report, my third-party audits, etc. I show them how we do this, walk through the exact technology, and within 40 minutes, the IT guy says, put it on, let's go. So what would have started with a no, I will never let you touch my network, is now, in 40 minutes, let's rock. Why? Because of that. Don't change anything you're doing. Leave it as is. That's all the deployment complexity. What is security? When we talk about security, and we're talking now security of the transport layer, right? I could very easily try and sell this, security, everybody's talking about security. Right? I never sell security. I never stand up to a page and a thing and say, buy us because we are secure. Because connectivity without security is the equivalent of buying a car without wheels. Connectivity without security is like buying a car without wheels. Anybody who stands up and say, use my technology to connect, and oh, by the way, I'm going to bolt on security, say thank you, bye-bye. It doesn't work like that. Security has to be built in from the ground up. Now, what does built in from the ground up mean? I'll tell you what we know of this thing, and I'll share with you. We have 8 layers of security only in the transport layer. Only in the transport layer. Because we come from a mentality that says, we will be hacked. Right? We start with that. There's a big line in the office. We will be hacked. Now build from there. How will the hacker think? How can we isolate? How can we minimize? How can we limit the impact of the hack? Nothing is 100% secure. Absolutely nothing. Anybody who tells you I'm 100% secure, give me about a supercomputer in 3 days and I'll break that freaking code. Nothing. Right? So, what are the layers of security? Start. Hardware root of trust. If you don't know what hardware root of trust is, hardware root of trust involves a tamper-proof module in silicon running on the gateway where all the certificates and keys are etched in silicon. There is no user, it's not software based, it's hardware based. The keys are etched in silicon. So I know that on the way from China to here, nobody interfered with the chip and put something into that chip. And it's a TPM module. What's the TPM module? Tamper proof. Somebody tries to open the gateway, gateway dies. Start, basic. Here's a piece of hardware. I want certificates and keys etched in silicon, and I want a tamper-proof module. Forget about it. We've not even come to software. This is just basic hardware. Number one, first layer. Second layer, a completely 7x24 managed secure operating system, which is patch managed on a 7x24 basis by us. A Debian Linux-based operating system running on the lowest level, completely hardened and patched by us. Why did we build this OS? We are not in the business of building operating systems. The reason we built it is, today you can go out and look for any OS and tell any OS on the planet where you don't have to hit enter. You try boot Ubuntu, you try boot Canonical, you try boot WindRiver, you try boot Windows, whatever. You try boot your own laptop. When you get a new laptop with Windows, what does it tell you? Enter something. And then only it will start. This fundamental requirement in the business of that we're in, of connecting buildings, if you need enter something, how do we scale? That is the reason we built this. The operating system is 100% cloud managed. There is no need to hit the enter key. That was the second layer of security. The third layer of security, absolutely no APN or VPN involved. Why is that a big deal? Because that APNs and VPNs require usernames and passwords. So there's no username and password. Eliminate that risk. Gone. Third. Fourth layer of security. Absolutely no change to the enterprise firewall or proxy policy. Because moment you have to whitelist something, that's one more possibility. So don't have to change that. Keep doing it. So that's the fourth layer of security. No changes to the enterprise IT, firewall and proxy policy. Number 5, we are a book-ended solution. We only talk to ourselves, and I'll explain how this works. Why are we a book-ended solution? Think for a second, right? This is not rocket science. When we go to FedEx and we are dropping a $100,000 demand draft in an envelope, sealing it, and we are sending it to your relative or brother or whoever, wherever you want, or an office, wherever, what do you ask for? When you are sending a very precious document in a FedEx envelope, what do you ask for? Pardon me? Signature. You want to know who signed for it. We do that in the physical world today. We go to FedEx, we put this signature required. Notice in the digital world, we've never asked for a signature on the return part. I have a VPN, great. So I send the packet out. Do you know where it reached? Oh shit, I don't know where. Do you know where it reached to the right person? No, I don't know. Of course you don't know, because you don't exist on the other side. The only way to know that the relevant packet reached the relevant entity is to have the other person say, "Ack, I got it." Okay, it went, I know. It didn't disappear into the ether, it didn't get rerouted anywhere, nothing. Now think, when it comes to a second reason for a book-ended architecture, what do you think is your biggest security vulnerability today in everything that you guys do? What do you think is your biggest security vulnerability? Open question to the whole room. Sherry is your biggest security vulnerability? It's a person, it's a human being. It's not a machine, it's a human being. And guess what, folks? That biggest vulnerability is inside your office. It's not an outsider. You can put all the firewalls in the world to protect everything. I can write a $50,000 check to a person who's behind on childcare and say, insert this. And we're done. All the security in the world is worthless. So what have you to protect yourself against first is a fraudulent employee inside the building who has the keys to the kingdom. Now think the book-ended architecture. So fraudulent employee is here, inserted malware into a machine. 90% of the time they want to reroute traffic. They want to steal traffic, take it somewhere else, take it somewhere where they can decrypt it, make some, whatever they want. They want to reroute it. With a book-ended architecture, you eliminate rerouting of traffic completely, period. Because this person comes in here, the first thing we see is, do I see my mirror image on the other side? If I don't see my mirror image on the other side, I am not sending a packet there. It's an illegitimate place to send a packet. You can try whatever you want, it's not going there, period. So I minimize the impact of this. Now this person could still bring the building down, I can't do anything about that, but they can't reroute traffic. What is the second thing I minimized? Denial of service. None of these devices below can ever initiate a DDoS attack. For those of you that don't know, a DDoS attack is when malware is inserted into a device and traffic is rerouted to a certain server and everybody bangs on that server and brings the server down. If you cannot reroute traffic, you insert, this thing says, sorry, I'm not going to transfer. So we eliminate DDoS, gone. So this is the 7th layer of security. Now there's an 8th layer of security. The 8th layer of security is complete isolation of every data stream. A containerized architecture that isolates every single data stream. What does that mean? We've got an LED light, we have HVAC, we have badges, access control. So we have 3 systems in this room already. Maybe there's something else. There's a fire alarm right there, 4. So there are 4 systems in this room. One is Honeywell, the other is Johnson, one is Trane, the other is Enlighted. One of them is BACnet, the other is LawnWorks, one of them could be Modbus, the other could be Ethernet. If one of these subsystems is hacked, you never want the hack to affect the other subsystems. So when you're transporting data through the same router, through the same network, all the way up, you want to ensure complete isolation. So we have a containerized architecture where every single data stream that's going through us between this gateway and this gateway here is completely isolated. Micro tunnels within tunnels, they will never touch, they will be isolated. The last layer of security is the OT traffic will never touch the IT traffic. So you're using the same infra that's carrying your point of sale, your ERP, your CRM, your HIPAA compliant data, that data will never touch it. Now this is the layers of security only in the transport layer. So this is what we mean when we say secure. When somebody comes to us, we use a VPN. I'm like, guys, let's talk. We will tell you what our experience is, and then you can decide how secure you are. So, and this doesn't mean that, and we keep improving on this. The more we learn, the more we improve, because there's vulnerabilities. But this is what we mean by security. All right. Now, so what's the net result of this that I've told you? We are the easy button. We eliminated deployment complexity. We eliminated security issues. Right? Deployment complexity, to be explained frankly, the 6 steps that involve deployment complexity. Whenever you want to deploy and connect a building, call 1-800-IT. IT shows up. Okay. We need to buy Cisco firewall ASA. We need to buy Palo Alto Networks, Cisco VPN concentrator and router, Palo Alto firewall. 2 boxes we already need to buy. Then we need to write some kind of protocol software adapter to convert Modbus to IP. Then we need to call AT&T or Verizon or Rogers, get an APN or a VPN. Then we need to get 2-step authentication. Now we need to call the enterprise IT guy and say, okay, we're all set, can you open up that port for me please? We can now tunnel out, or change whitelist me so I can tunnel out. All of this, typically a 6-week minimum to a 6-month period to connect one asset to one cloud, or one asset to one data center. 6 weeks to 6 months. We've made that entire problem a 6-minute problem. Box is dropped, connect, turn on, 6 minutes, you will see data, period. So that's that. What is future proofing? If you think about buildings that you're going to connect, right? How many of you are familiar with Niagara by any chance? Tridium Niagara? Okay, well known. All right. Tridium Niagara, SkySpark, DG Logic, FinStack. These are all analytics programs that you run at the edge, run at the building. All right. In simple words, let's say you are collecting data. This has, this is maybe 20 megabytes of data per 10 minutes. Or just we're taking a number. So if you're constantly sending 20 megabytes of data per 10 minutes up to the cloud, that's a boatload of data going up to the cloud. So what you want to do is you want to run as much of your processing at the edge and minimize the amount of traffic going up to the cloud. There are latency issues, etc., that come in the way, but that's what you want to do. So now think, if you want to deploy an application across his 1200 branches or his 80 substations, what are their choices? One choice, take 1200 USB sticks, send it, give it to somebody and say, go take this software, install it at the 1200 manually. This is choice 1. Choice 2, take 80 of these boxes, these appliances like this, they have my software already installed on them, go and plug it in. Okay, fine, we took the 80 and we plugged it in and it worked. Tomorrow you decided, no, I want to deploy some new software. Now what do? Now you have another 80 different box, because this one has encryption, the next one has compression, third has dedupe, the fourth has machine learning, the fifth has artificial intelligence. So what does that mean? What that means is the edge needs to be completely virtualized, hypervised. What you do on AWS today, flip it around, make it do it here. So multiple people with one click can push any application from the cloud here, and it will run in its own isolated compute and memory environment, completely isolated. So these are containers that we built where anyone can, today you want to deploy ThingWorks, tomorrow you want to deploy Sky Foundry, then you want to run DG Logic, Flutura, any application you want to run here. It's all, there's an entire industrial app store in the cloud. Literally, just like your Google App Store and your Apple App Store, there's an entire industrial app store. All the protocol software adapters, analytics engine, encryption, compression, dedupe, DPI, machine learning, AI, all these are available there. from third parties. You buy the license, choose it, and you hit push, and instantly it will get deployed to all your 1200 branches, all your 80 substations, whatever, instantly. And it could be any application from any vendor. You could write your own. You could write your own in Python, C++, Java, whatever you like. As long as you can containerize it and it will run on Docker, which means it will run on Linux, it will work. That's all. Right? So that is future proofing. You are not worried that today I deployed this box, will it work for the next 4 years? Will I be able to deploy new software on? That all. So what this means is this edge device at the edge is the following. It's a VPN concentrator, it's a router, it's a switch, it's a hypervisor, and a firewall, all combined together, software, in one substrate, 100% managed from the cloud. That's what this is. The same software resides at the other end, but in the form of a virtual machine. And now I'll explain that architecture to you. Any questions so far on at least the problem statement? None? This is what today's world looks like. These are HVAC, lighting, whatever, security, all those subsystems. Different subsystems, different manufacturers, different protocols. SCADA, Modbus, CAN bus, OPC, BACnet, LawnWorks, Honeywell, Train, Allerton, Enlighted, whatever. Plethora of protocol software adapters, bunch of network infra availability, so you can go 3G, 4G, satellite, MPLS, T1, and then of course a whole bunch of operators over there. Typically, when you have to connect this HVAC data to that HVAC cloud, all the 6 steps we mentioned, right? Install firewall, write VPN concentrator, call operator, get VPN tunnel, get 2-step authentication, all of that. So what did we do? We said, let's take that entire layer that you see over there, completely abstract it out. Now think for a minute, think Skype. How many, you've used Skype here? People here, right? Okay, if you think Skype for a second, right? When you're using Skype, there's 2 software clients. Do you care whether you're on a Windows tablet, whether you're on a tablet, handset, or laptop? Okay. You care Windows, Mac OS, Android, 3G, 4G, MPLS, T1, Ethernet, Wi-Fi, Rogers, AT&T, T-Mobile, AMD, Intel, Symantec, Mac, all, you don't care. That entire stack has been abstracted out. They gave you 2 clients, you hit click, a secure peer-to-peer voice tunnel is created, and you have a voice or a video call. You really don't care. You don't even think twice what operator you're on, what infra you're on, whether you're a handset, tablet, oh, I'm Linux, I'm Android, I'm this. None of that. So why should we care about that when you're doing machine-to-machine communication too? We shouldn't. So that's what we did. We abstracted out the protocol software adapter layer completely. The protocol software adapter layer now resides in the cloud. There's a full library of protocol software adapters. Anything to convert from X to Y, click, enter license file, push, protocol software adapter deployed. Now why would I want to do this? Think for a second now again, why would I want to do this? Today I decided I connected my lighting system. Great, I have a box, my lighting system is connected, I'm getting all this data to the cloud, I'm very efficiently managing my lighting. Tomorrow I decide, hey, I want to connect my HVAC system. Why not match the 2 and do that? Okay, the box is there, the interface I connected. Oh, but that one uses LawnWorks and this one uses BACnet. Now what do? How am I going to understand this? So now I have to push a new word. Oh no, now I don't have the adapter, I have to go send somebody out there to install. So if you had it in the cloud, wouldn't it be easy? I don't care what protocol you want, all the adapters are available in the cloud, 1 click, push, deployed, I'm done. So you notice how we future-proofed you completely. You can keep thinking, now I'm going to write my own protocol. There are cases where there are proprietary protocols, completely closed, nobody understands it other than the company that wrote it. So they have custom fields where they can write their own protocol software adapters and push it. Right? We abstracted out the infra layer. Now you don't care whether either side is on 3G, 4G, MPLS, T1 satellite. You don't care anymore. We abstracted out the operator layer. You don't care whether this is Rogers, Etisalat, Singtel, Do, Verizon, AT&T. You don't care. All gone. Lastly, we abstracted out the security layer. On either side, you can be wide open. We will guarantee that this virtual overlay network here will completely protect your data. Nobody is ever going to be able to reroute it, no man in the middle attack, no rerouting, no DDoS possible, nothing. Data will go only from the source you said it's supposed to go to the destination supposed to, period. I don't care how insecure both either ends are. So all those four are completely isolated. The secure perimeter is the built-in firewall, which is this blue line. It protects everything south of us, right? Now's the fun. Once you control that layer, what all can you do? We'll talk about quality of service. What is quality of service? Quality of service is two kinds: link layer quality of service and application layer quality of service. What is link layer quality of service? Link layer quality of service typically applies in a mobile asset. You have always been in a train or a bus or a cab or wherever you're going. At some point in time, the signal on AT&T dies or is getting weaker. And then somebody on the Verizon phone has a better signal. Say, can I use your phone? You've all experienced that. That is because coverage in one area was better than coverage in the other. So what is link layer quality? It says, if my AT&T latency reaches X, turn on my Verizon modem. If my Verizon modem latency reaches Y, turn on my T-Mobile modem. So you can hop from modem to modem on the same box. You just hop. You can also hop from infra to infra. If my latency on 4G reaches X, turn on my satellite modem, and vice versa. So that's link layer quality. It's about the link quality. Now there's application layer quality. Each of those guys on the top says, if the pipe is shrinking, for me, lighting data is most important. For me, access control data is most important. For me, I don't care about both you guys, I want the HVAC data. So how do you allow multiple entities in the cloud to set policies as to if the pipe is shrinking, this is most important. 9/11 happens. There's a camera over there. It's collecting parking meter data is also going up, red light, traffic light data is also going up. Do you think anybody cares about traffic light and parking meter when 9/11 happens? What does everybody want to see? The video. So give the entire pipe to video, stop everything else. That's quality of service. So you can start doing. That's application layer QoS. Okay? WAN optimization, edge compute is the ability to run applications at the edge, which we've already spoken about. Right? The ability to push protocol software data, encryption, compression, dedupe, run it at the edge, fully virtualized. WAN optimization is the filtering. Why do you need filtering? Classic example. This room is at 72 degrees. Is there any value in sending that data every minute all the way up to the cloud? Room is at 72, 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 room. What do you think you're going to do with that data? Just going to trash it. So you spent all this money pushing the data all the way up there, went into AWS storage and then trashed it. So what that tells you is sending all the data all the time to the cloud is stupid, doesn't make any sense. Sending relevant data to the relevant entity at the relevant time is the only thing. What is that relevant data? The room temperature suddenly went to 78 in the past 3 minutes. Something's going on, something stopped working. Send me immediate, send me the log of the past 5 minutes and then immediate. Now it's interesting, right? Now you want to look at it, something's going on, what's happening? Or the temperature just dropped, or the lighting just went off, whatever, all of that. Or it's about to go off. So WAN optimization is where each entity in the cloud, all those 5 guys, can write their own filters. This data is important to me only if, send me value if, think about this. This HVAC data is going to 2 clouds. It's going to the HVAC system for preventive maintenance. This is Honeywell, going up there for preventive maintenance, and it's going to an analytics cloud. The analytics cloud wants the data every second because they're running analytics. The preventive maintenance guy wants it every 3 minutes. So you want the same piece of data. One guy wants every 3 minutes, the other wants every second. So that's filtering. They can all write their own filters and dynamically change it on the fly daily. All right? That's the WAN optimization. All of this, by the way, is going to be demoed by him right now in the next 10 minutes or so. This is why people buy us. I never sell security. I told you. Connectivity without security is like selling a car without wheels. So I'm never going to harp and say, we are the most secure, therefore you have to buy us. No. I say, I will, whatever you pay For 1 hour of a IT guy, I will give you 1 year of a managed service. Zero touch. And by zero touch, it's 100% zero touch. You will literally drop ship boxes to 1200 locations, to 80 locations. That regular technician, no Cisco, no IT guy, with the guy with the spanner can say, plug the blue cable, yellow cable, turn it on, leave. We're done. Building is connected. That's what that is. Patch management. Let's talk about patch management. How many of you heard about that? I believe it was the Murray attack on the camera. How many of you heard about that one? This happened about 6 months ago. 400,000 cameras got hacked. It was a Murray attack that created a DDoS attack from that. The virus was Murray. The vendor of the camera instantly came up with a patch. He came up with a patch today. Like instantly, within 5 minutes there was a patch ready. The 400,000 cameras are across 20 cities all across America. How do you patch that? You need to patch firmware on that camera. Think about, oh, I have to send a body out to each camera, climb up on every pole. Madness. If they were using us, that patch would be put in our Orchestrator in that app store, and you hit push. Instantly. Within 5 minutes, all cameras would have been patched. So the first patching is patching of the firmware of the devices. Right? That's the first level of patching. What is the second layer of patching? Patching the operating system that's running on the gateway. And new Linux vulnerability will be found, don't get me wrong. It will have to be patched. Now, how do I patch 1 million of these guys that are out there? So you have to have the capability to push patches for the OS. What is the third thing you have to patch? Patching the applications that are running on this in a container. Encryption, compression, dedupe, DPI, machine learning, analytics. More vulnerable, so you have to patch that also. New Rev 2.0 has come about. So all 3 levels of patches now completely managed from the cloud, right? This is what that same picture suddenly looks like. This is now we're into the solution. This is what the solution looks like. The solution has 2 components to it. It has an inode and it has an orchestrator. The inode is a piece of software. It's not a box. It's a piece of software. It resides at the data source and the data sink. The data sink can be a public-private hybrid cloud. It can be a public-private hybrid data center. It can be your office. That could be the data sink. That 1200 branches, wherever you want that data to come, that's the data sink. That's it. The data sink, given that it's an office or a public-private hybrid cloud or data center, you have a hypervisor available. Something called VMware or OpenStack is available. Because you have VMware or OpenStack available, you can run us as a virtual machine, which means you do not need any hardware. So right on top over there, we are running as software. There's no hardware involved. There's no box or anything. It's literally a piece of software running as a virtual machine on VMware or OpenStack. If you had VMware or OpenStack in your respective building, we would run as a software piece of software there too. But 90% of the time when you go into the basement of your building, nobody has put OpenStack or VMware over there. Nobody's put a hypervised environment. That's the reason we reside on certified third-party hardware that looks like this. This is one box. There's another box here from Dell, and then I'll show you some more. We are the actual Debian Linux-based operating system on this box. We are the lowest level of software on this box, completely hardened and patch managed on a 7x24 basis. We reside on any certified third-party hardware box. Here are some samples for you. Now you'll ask me, how do I choose? Which one should I use? Here are your parameters. What physical interfaces do I need? Do I need RS-232, RS-485, CAN bus, Modbus, Ethernet, Zigbee, Z-Wave? What is the physical transmission that I need to connect to? So physical interface, that's first. Second, how much memory and compute do I need? Am I going to run encryption, compression, dedupe, DPI, machine learning, AI? Or am I just going to take everything to the cloud? My request and suggestion to every single one of you, always buy the most amount of CPU and memory. Why? ripping and replacing a box will cost you way more than adding $100 now and getting 300 more MIPS on that box in CPU and memory. Why? It future-proofs you 2 more years. You can now deploy the next. Have you all seen what happens? We are now talking to a laptop 4 gig, 5 gig memory stuff. I mean, things we used to dream about 10 years ago, right? Why? Because people are writing such lazy applications that pathetically use memory, and they're deploying it. That's the reason. No optimization, nothing. So this is what is going to happen in this world also. There's no, people are going to write applications that require CPU and memory. So you're better off buying a CPU and memory and deploying it right now when you're doing it, rather than thinking, oh shit, I wish we had more CPU and memory so we could run something more. Because then you have to either deploy a new box or you have to rip and replace, which is more expensive than. So that's that. Hardened or not hardened environmentally. And number 4, the first thing I spoke about, hardware root of trust. Are you interested in having a tamper-proof module which is fully 100% root of trust guaranteed? If somebody tries to open that box or do anything, the box will stop, dead, finished. So that's how you decide. We are available on all of this, both ARM and Intel. You can decide what. Now, let's talk about how do you deploy it. This is the solution. How do I deploy it? Let's say we'll take the bank branch example. System integrator wants to connect 1200 branches. This is one branch, this is branch 2. There are 1198 more like this. So system integrator logs into Orchestrator. Orchestrator is a managed service. It runs on Amazon Web Services. It's completely multi-tenanted. Most of our customers, 99.9% of our customers, white label it and use it. Okay? That's for control and management purposes. Larger customers like Halliburton want to take that and put it in their data center and manage it with their IT staff. More power to them if they want to do it. We license it. But most customers just white labeling it. So SI logs into the Orchestrator. It will be white labeled. It looks like the SI side. Nobody knows IoTM exists at the back. Once they log into the Orchestrator, they create tenants. Tenants are those 1, 2, 3, 4, 5 guys. Whoever you want to send data to is a tenant. Moment they create tenants, these 5 people can log in under the SI's account into the Orchestrator. They all log in. One of them is on Azure, the other is on AWS, the other is on IBM Bluemix, one is a private cloud, one is his office. They've all logged in. Each of them get an image of the inode software that they can install in their respective. They get it for free. It's immediately, here's your instructions, install the VM. They install the VM. Now SI will call Yorkland and say, Yorkland, I want 1200 of these boxes. And I want 1200 of these boxes with the inode operating system on it. Here are the address of the 1200 branches you're supposed to send it to. Yorkland will get it from Arrow, who is the person who does all the manufacturing for us. And those boxes will drop ship to the 1200 branches. They will literally show up one day like a DSL modem at your doorstep. When that box was manufactured, Arrow and Avnet are our distributors. I don't know if you know of Arrow and Avnet. These are large, like CDW, procurement houses where you buy IT stuff from. They have been taught how to load the OS, how to put the keys in the Orchestrator and all of that. So moment the box reaches the branch, somebody whoever is there, opens the branch, says, here is the yellow cable, plug it into the JACE or the building automation system. Here's the blue cable, plug it into the Ethernet switch for outbound. If you don't want to use Ethernet, just turn the cellular modem on. Both options are available. Box, you turned it on. Through absolutely any firewall or proxy on the planet, 99.9% of the time, using outbound 443, which is open. If you can go to google.com through guest Wi-Fi, 443 is open. Your best way to check is you can send a high school kid to install this. He takes a laptop, goes, yeah, I can go to google.com. Good. Take this box, plug the yellow cable, plug the blue cable, turn it on. Leave. You're done. This will go out, get authenticated to with the Orchestrator. Certificates and keys. Yes, ma, I belong in the right place at the right time. This is the branch I'm supposed to be at in Ontario, in Toronto, in this neighborhood of Toronto. That key has been matched, what location it was going to, etc. Once it's matched, now policies get downloaded onto this box. What are the policies? The first level of policy is what node is supposed to talk to which other node. It's just a click, click, click. If I want this HVAC data to go to the HVAC cloud, click, create a tunnel. This node should talk to that node. If I want this lighting system data to talk to the lighting cloud, click, this node should talk to that node. That's it. Everything else is gone. There was no APN, there was no VPN, there was no operator, there was no username, there was no password, no IT guy to call, no firewall change, nothing. Click, you create a tunnel. Secure. The second level of policy is what data is coming on what port. When this box ships, it's a dead brick. Not a single port on it. You cannot take a keyboard to it and boot it. It's not going to boot. I told you, it's 100% cloud managed. It cannot boot on it with a keyboard. So you have to tell it policies. Hey, fire alarm is on RS-232, security is on RS-485, lighting is on Ethernet, something else is on Zigbee, something else is on Z-Wave. Accordingly, it will open up its port and say, okay, now let me ingest that data. Last thing, based on the number of destinations in the cloud, that many containers are created on the fly. Remember the hypervisor, the virtualization, the isolated compute and memory environment. Each of those 5 guys has its own isolated compute and memory environment. Data from here is being copied into those containers. So they may think you're accessing, no, you're accessing a container over here. And now, from the orchestrator, each of those guys can push whatever application they want in their container. And that's how we achieve that complete isolation. Remember the HVAC data not talking to the lighting data, not talking to. It's a fully containerized like that. Here's an animation, and then we will go to the demo. Where's the animation? Here. Box turns on, goes out, gets authenticated with a bunch of certificates and keys. Now policies will get downloaded. These are your policies that the SI set. Once the policies, now it forms a secure peer-to-peer tunnel. It has a built-in firewall, protects everything. Now it will form a peer-to-peer tunnel, straight from the source to the sink. No data ever comes to IoT. Data goes directly from source to the sink. This is the isolation. All these 3 streams will never touch each other. This stream will never touch. This is the containerized architecture. Remember, data is copied into each container and completely isolated. Now everyone can push any application they want from the cloud here. You can push Niagara, you can push Sky Foundry, these are building automation applications. You can push encryption, compression, your own custom application, whatever you like. You can push it at the edge. Everything is multi-tenanted. Here is a screenshot of the orchestrator. If you want to know, Ron has been saying you can push these applications. How do I push this application? Well, here you go. You come to the orchestrator. These are applications, SkySpark, ThingWorks Edge, Relayer, Custom, there's a bunch more. He'll show you the live one right now. You choose the application, enter the license file and push. Multiple floor nodes can talk to a building node. Multiple building nodes can talk to a campus node. So you have a hierarchical architecture. Bank of America, Merrill Lynch, Chase, different. So you want an inode per floor. Hilton Hotels, whole hotel, I want an inode per building. Intel's campus, I want a floor node, this and that, so I can isolate and run analytics on a floor level, how much energy is being consumed per floor, how much energy is being consumed per building, how much energy is being consumed per campus. All of that is completely possible. Good. So if you need Yorkland controls right here,